Okay, it's 11:30. Let's start with the presentation, open source projects and secure boot. First of all, pardon me, I'm not a native speaker, I'm from Germany. Please, I apologize up front if I misspelled some things. And this is my first presentation in English, so be kind. So, who's the guy with this weird accent? I'm Matthias. I finished my master's in computer science in 2015, and since then I'm working for the company UIB based in Germany, where I'm mainly involved in the development of so-called netboot products. This is something I'll explain later what this is, of our boot image we use for PXE-boot, and of the secure boot implementation within Opsy, which I'll present today. And from time to time, I'm also on the support hotline and email support from the company. So first of all, what is secure boot? By definition, secure boot is a verification mechanism for running trusted code in the Unified Extensible Firmware Interface, UEFI. Is it correct, UEFI or UEFI? UEFI, okay. So UEFI uses cryptographic checksums and signatures to verify the stuff that is getting booted. Every device contains hardware vendor keys, also known as a platform key, but in addition, therefore, because platform vendors want to sell stuff, they add the Microsoft key, so Microsoft can come pre-installed with secure boot enabled. And one of those keys that is added by the platform vendor is also known as the key exchange key. There can be a Microsoft key, there can be a Ubuntu key, or any other key. And Linux distributions support secure boot for a long time. One of the latest entries is Debian 10, with Buster just announced that they have secure boot support. And then is the question, what is secure boot not? So secure boot at first is not an attempt to lock out non-Microsoft operating systems, and therefore Microsoft acts as a CA to sign bootloaders, drivers, and other components that are booted. It's quite plausible why they are doing it, and 99.9% in the case there's the Microsoft key installed on the machine, therefore Microsoft offers this service. And Windows 8 released in October 2012 with the first initial secure boot support from a Windows system, and Fedora 18 released in 2013 and also added secure boot support. So they already, in 2012, they already wrote white papers together with OpenSUSE how to do all the secure boot signing stuff so Linux can support it. And secure boot is also not an attempt to lock out users controlling their own system. The pre-installed keys can be deleted, usually via the UEFI. And users can also enroll own keys onto their system. Yeah, if they own them, they can enroll new keys. But what secure boot is also not is a protection within the user space. So you get a virus that messes up your file system. Secure boot does not protect you from this. It only secures the boot process. So what are the advantages of secure boot? At first, secure boot protects you from malicious code during the boot process, which is also known as a bootkit. And the system refuses to boot if there is any component signed with a wrong or non-existent key in the system. So therefore, every booted component in the so-called chain of trust is checked by the signature or checksums if this is a valid signature or checksum. The list of checksums and signatures is stored locally, but this list can be expanded by the user. If they want to sign their stuff with their own key, they can add this own key, and therefore this is then accepted as valid. So what are the disadvantages of secure boot? Microsoft acts as a CA. So you can be a friend of Microsoft or an enemy of Microsoft. Microsoft is the only institution that acts to sign secure boot stuff, because their key exists on almost every machine. The system platform key is not in user hands. It can be deleted, but to replace it in a programmability way, you would have to have a new key signed off with the platform key to replace it. So you would have to go to the hardware vendor and ask him to sign your stuff. He won't do this. VirtualBox had a couple of issues when they first released on Secure Boot-enabled devices because VirtualBox adds DKMS drivers. At the beginning, those drivers were not signed, and every component that is added into the boot process after the system is installed also has to have a valid signature. Those drivers weren't properly signed, therefore the system did not boot into secure boot mode or did not boot at all. And if your signing key gets into the wild, into the wrong hands, then the whole security advantage is gone. Then everyone can sign his stuff, even if it's malicious software or boot components, and execute this and hack your system. Downside is also, if any hardware vendor wants to update a deny list, in the UEFI there's a deny list of signatures and checksums. So the hardware vendor has to offer a UEFI update, so this key in the wild gets blacklisted. And also a custom kernel on a secure boot supported distribution is not possible. You would have to ask, for example, Canonical to sign your stuff. They won't do it because they don't know what you have. So how is this chain of trust built up? At first, we have a platform key. This is usually distributed during the OEM process of the hardware vendor. We have the key exchange key, which is by default the Microsoft key. There's a list of allowed signatures and checksums, which can be expanded, and also the deny list, which contains keys that are not allowed within secure boot. And how does this chain of trust work in this way? So at first, we have a UEFI that boots, which contains the Microsoft and the vendor keys. It loads a bootloader, which is by default signed off by Microsoft. And we have, here in this case, a Microsoft kernel, which is also signed by Microsoft. So it shouldn't cause any problem. If you distribute your own keys, you have the UEFI, which contains Microsoft, vendor, and your own keys. You can sign your own grub bootloader and also sign your kernel. Therefore, this is all accepted as valid. And how most Linux distributions use it, for example, they have the UEFI, which contains the Microsoft and the vendor keys, so they don't add their key to it by default. They ship a shim. The shim contains the key of the project, maybe Ubuntu, CentOS, Debian, or Fedora, which is signed by Microsoft. So this is the thing where Microsoft gets in. They sign this, the shim compiled by the project, and therefore everything that is later signed by this project key is also accepted as valid without the need of adding this key to the UEFI. And if anything breaks within this chain of trust, you'll get such a fancy note that something is violated. Please check your setup. Or this machine can also boot, but it will not boot into secure boot mode, depending on the setup within the UEFI. So how do you implement such a chain of trust? You can deploy your own keys. To deploy your own keys, you have to install them on your machines. This is either done directly through the UEFI or the machine owner key or MOK manager, and this cannot be done unattended. So there's no way to automate all this process. Someone has to sit there physically, click through the menu, select passwords, and add every single key. So if you have 5 machines, feasible. If you have hundreds of machines, you won't do this. You don't want to do this. And there's the other way to get the chain of trust. Get a shim signed by Microsoft. Sounds easy, is a bit hard. First of all, you have to get certified by Microsoft. To get certified by Microsoft, you have to sign a binary you download earlier from them with your extended validations or EV certificate. Then compile your shim with the public part of your key. Sign this, and then you get this signed from Microsoft. Then you can deploy this shim onto all machines without the need to deploy your keys directly. So how did we implement this? So I'm from the company UIB. We have a product called Opsy. Opsy is short for Open PC Server Integration. We offer a framework for client and configuration management with which you can deploy software, provision the operating system, Windows and Linux clients. and perform a hardware and software inventory. Currently, Opsy is running on standard x86-64 hardware and also ARM7 devices like Raspberries, Banana Pis, Odroid, or yeah, the same. Yeah, you may not know Opsy. It's mainly because we are a German-based company, so therefore we are mainly used in the German-speaking area. And as for the US, you see there are not so many installations. Those are not tracked by us. Those are so-called dots on the map, on the Opsy map, that are given by the administrators. So it's not that we track installations. We do not get any telemetry at all from the users. So for example, here's the county of Ventura that uses Opsy. Here's an Army department, Department of Work. So they are using Opsy, and we don't know except for all the dots that we see on the maps. So the Opsy project originated in the Hessian State Office for Environment and Geology in 1994. The original name was HUPSI. HUPSI stated for the Hessian in the name. The first task of HUPSI was to automate Windows 3.11, the provisioning of Windows 3.11 on the server machines of this state office. And then in 1995, the original members founded UIB because they thought this is something everyone could benefit from. Everyone could benefit from deploying Windows in an automatic way. So they renamed HUPSI to Opsy, and the first official release of Opsy was in 2004, and since then we give out new versions, develop new features and extensions for it. So what Opsy does, it does operating system provisioning for Windows and Linux clients. On the Linux side, it's Ubuntu, Debian, Red Hat, SLAS, OpenSUSE, and CentOS. And on Windows, all current supported Windows versions, client and server side. And as for the software distribution, Opsy offers a service to distribute packages and configurations for those clients. This is doable on Windows, Linux, and the current beta phase is running on macOS. And as for the inventory, we use standard OS commands like WMI or lspci, lsusb to gather the hardware data. So as for the OS provisioning, how does it work? We perform a PXE boot or UEFI net boot, where a minimal Ubuntu-based boot image is started. With an own custom kernel, we try to always have the latest kernel running, so therefore we can always support the latest hardware. We do not rely on the Ubuntu kernel. So when the boot image is booted, we pre-partition the disk, also patch the unattended installation file for the desired operating system, like the unattended XML for Windows, preset autoyast or kickstart for the supported Linux distributions. And then we start the operating system installer. We do not want to reinvent the wheel. We use for example, a Windows pre-environment to install Windows, or the desired distribution installer to install it. And we do this via a reboot or a kexec. Oh, wrong button. So how does the software deployment work? We have an own client agent that connects to the server regularly on boot. You can configure it to connect to the server on shutdown, or you can deploy software on demand. We have an own scripting language called OpsyScript, which is mainly used for the workflow of the script, but in the end, OpsyScript uses also standard batch, PowerShell, or shell commands to execute stuff. Yeah, we don't want to reinvent the wheel. Why? Because there's already stuff working for it. And Opsy can also coexist with other configuration management software like Chocolatey. All tools to create packages, to create the configurations are free to download. Anyone can use it. The documentation is free, so feel free to try it if you want. So the Opsy core is free to use by anyone, any corporation. We are not like we're not coming to you if you have a company. We don't track you, so it's not like you're depending on us. We give you all the information you need, so you can start using Opsy without the need of us. But we also need money. We're a company. So how do we make money? We make money by selling support contracts, selling package subscriptions, like for example Windows updates, Office updates, and basic features like browsers and, for example, PDF readers, mostly used by Windows users. We offer trainings in-house or in our own training room, and we sell so-called co-funded modules. So we have a co-funding, which means we invest in a specific amount of money into developing a new feature, then we start selling it. If we get the money back from selling this feature, we give it out for free to anyone. So anyone can then use it. The more people buy it, the earlier it gets out for free. So yeah, Secure Boot, for example, is such a currently co-funded module as this released by the end of last year. Who uses Opsy? So we have different use cases for Opsy. For example, city councils, hospitals, universities, schools, state offices, banks, research institutions, companies and associations. You see there's a whole wide range or spectrum of users. They all have different needs in case of packages, in case of security, and Opsy fits all of them. Yeah, this is an example. A customer sent us, he's deploying his ATMs with Opsy. And sometimes when a colleague is in a training with a customer, they send us such images where they just deploy a room with, for example, here we have 20 PCs just installing Windows currently. And if you want to know more about Opsy, oh no, there's another slide. What we do with Opsy, for example, we created an own test environment. So we use Opsy to test Opsy. What we basically do is we have an Opsy server that deploys all current supported Linux versions, installs Opsy on them, adds a client, and reinstalls this client. So we will verify that the standards or the base functionality is given on every distribution. As you can see, sometimes tests turn red. Usually the, let's say, stable distributions are, yeah, you see a good sun, so it means last fail is a long time ago. And as for OpenSUSE 15 and /15, sometimes /12 fails. Yeah, it happens. We have to fix this. But usually, Opsy runs well. We have customers that are running latest / distributions, and they are fine with it. So here we have the overview. Again, we're deploying all Linux versions, and then on each client, we're deploying Windows 7, 8, and 10 to verify this works. And if you want to know a bit more about Opsy, last year we had a Floss Weekly interview, which was, I don't know, anyone of you listens to Floss? OK, so maybe you heard of it. And yeah, to the other ones, you can rehear it, episode 535. So back to Secure Boot. As I said, there are two ways to implement Secure Boot in your environment. First of all, create your own keys. So you have to manually deploy all keys, the keys on every single machine. In a case where you have lots of machines, this means you have a lot of work to do, as someone has to be physically in front of this machine to do it. The other way was to get a shim signed by Microsoft and deploy this shim with every UEFI netboot. So therefore, this key is in temporary memory of the UEFI. Yeah, so it's clear we decided for this way. But how this all worked out is also something I'll show you. So first of all, we had to register at Microsoft. Microsoft offered a platform called SysDev, where you had to download the binary, sign this binary with an extended validated certificate. If you don't have one, Microsoft offers to buy one for $99. And then you had to pack this file in a cap file and upload this signed file, including a timestamp, back to Microsoft. Sounds easy. But back then, this platform only allowed uploads with the use of Silverlight. Silverlight back then was beyond broken. Every browser blocked Silverlight. So we had to use some old Windows 7 machine with a very outdated Internet Explorer to upload this. And then things happened. Microsoft moved the platform from SysDev to developer. They already announced it in the process where we uploaded the file, but we didn't want to wait. So they moved. We also moved on. We compiled a shim with our own Opsy certificate, with the public part of it. We then got to Microsoft, uploaded this file, and asked to get this file signed. And after about 2 months, we received an email that we have to validate this shim on GitHub. The documentation was very vague on all those cases, so if we would have known, we would have done this earlier. So OK, then we went to GitHub. There's a Red Hat repository in GitHub, and there's one project for the shim review, so they outsourced it. We've been the 29th issue for this. We had to fill in lots of data. For example, first of all, we had to fork the shim review. We had to fill in the README file where they all wanted to know, who are you, why do you want this thing signed, how do you secure your keys, who is responsible for all of this, what is the version of package ABC that you use to compile this file, what is your version, what was your kernel version during the compile process. They also wanted the log, they wanted the public part of the embedded certificate. They wanted the patch files, so they could, in the end, what they did is to rebuild the shim with the data we provided, to verify a hash sum of it, so they could verify the hash sum of the file we provided and the one that dropped out during the build process by them. So if you take a look at the date, this was done on 23rd of August, 2018, and by just January of 2019, we had a positive review. So what they tend to do, basically, is they have two persons looking at this file to verify it. So this guy, Cyphermox, which actually works for Canonical, verified it, so the hash sum matched, and he assigned another guy, who I don't know, I couldn't track him, assigned another guy to also check it. This guy didn't respond within 5 months. So after we got back and asked how the state is, then he said, OK, my review was fine, so here's your OK. Then we got back to Microsoft with this hardware platform. And, well, what happened? So the review took more than 5 months. We got back to Microsoft, and yeah, guess what? Our submission timed out. So what we then did was resubmit this file with our positive review. So we wrote an email to Microsoft, to the designated person, since we already had the contact with them. So we wrote an email. So yeah, we have a positive review. How about the signed shim? And within 2 days, we had a signed shim from Microsoft. We then deployed the signed shim on our test servers, and after a couple of issues, we had a working secure boot deployment working with Opsy. So how does it work? This is a slide I showed you earlier. So we follow the way Linux distributions do the secure boot process. We have a UFI which contains the vendor keys and the Microsoft keys, which loads the shim via UFI netboot, which is compiled with our keys, signed off by Microsoft. We take a grub. Usually, in our case, we took a Ubuntu grub and just wrote. We just have overwritten the signature of the Ubuntu grub with our key, and then we start the kernel, which is also signed off with our key. So how does it look? So at first, when a client starts the UFI netboot, he gets a DHCP address, and the DHCP has to decide what kind of client are you. Usually, when a client gets to the DHCP, it sends an identifier. By default, the identifier is 1. This means that this is a standard BIOS client. And on UFI, oh no, this is 0, sorry. And on UFI, the identifier is 7. There's no way to distinguish if this is a secure boot client or if it's a standard UFI client. So therefore, we provide this shim. We got signed off by Microsoft to any UEFI client. And when the client has no secure boot turned on, it just don't verify anything. So it gets along with the signed shim. And what the signed shim does, here we have an overview of the TFTP process. Here at first, the DHCP sees, OK, I have a 64-bit UEFI client, gets an IP address, then it gets the file. After it got the shim, it chain loads the grub. The grub itself tries to load some files. In the end, it loads the menu. And when it's in the menu, it tries to distinguish or to find a so-called, we rely on named pipes. So what we do, when an operating system is about to be installed, we create a named pipe that contains the data that what to chain load next. And after this file has been read, it disappears. So we just need it once. And in this case, the grub config sees there is a named pipe, and then it chain loads our kernel and our mini root that we created based on Ubuntu. Here we have how the grub configuration looks. The good thing about grub is, yes? Pardon me? No, it's not. So basically, yeah, it runs in the RAM, but it's not in ramfs like Ubuntu provides. So good thing about grub is that the grub itself is scriptable. So what we do is we read the MAC address of the client, and with a bit of regular expression magic, we transform the MAC address into the how do you call it? How it should look for our named pipes. So we have one standard for named pipes, and it gets transformed to the standard so it can be read. And then the grub configuration checks if this named pipe exists on the TFTP server. If yes, it loads it. Otherwise, it shows a menu, which by default has the local disk entry at first. And then otherwise, you can decide to load the boot image itself from TFTP. And within this boot image, which is currently based on Ubuntu 18.04, you can check if the machine itself is in a secure boot state. So with a tool called mockutil, and the variable or the parameter as bstate, you can check if this is in secure boot or not. And we also provide, if you're sitting in front of the machine that's getting deployed by Opsy, within the boot image we are providing information like, okay, we are running in UEFI mode, we are running in secure boot mode. It pre-partitions the disk. This is a Windows installation. And yeah, so it creates a system partition. It creates a WinPE partition for the pre-environment to run. And then after it finishes, it reboots and gets into the WinPE partition. And on a Windows system, you can check if the machine is running on secure boot mode. This is a test I did last week to verify that this works. So how is the installation procedure? For Windows, it's quite easy. We have the UEFI with standard keys. We have a shim compiled with R keys signed off by Microsoft. The grub is signed with R keys. Kernel is signed with R keys. The machine reboots, gets again into UEFI, starts the WinPE partition, which contains a Microsoft signed bootloader, reboots again, and then it boots into ready Windows 10, for example, which also contains a Microsoft signed bootloader. Things get a bit different when we want to install Linux. So the first step is always the same. UEFI, shim signed off by Microsoft R keys, grub R keys, kernel R keys. But then we do a kexec into the installer kernel. For example, if it's Ubuntu Debian. Thing is, they are usually signed by Canonical or Debian. What we do then is we overwrite the signature of those kernel files. And then, so we can start from one kernel to another. Otherwise, it would break the chain of trust, because the canonical or Debian key is not in the UEFI itself. So we have the installer kernel signed with R keys. Then it starts the init RD of the kernel, reads the preseed, performs the unattended installation, and after a reboot, the shim is loaded by the UEFI, which is then compiled with the distribution keys and also signed off by Microsoft. So then we have a normal Linux boot as if it would have happened via CD or USB stick. Yes?
The project keys are in a regular GPG key ring. You could just import the distribution keys.
I don't think that they are regular GPG keys. This is some X509 keys, SSL. So, and another possibility, because sometimes machines tend to have problems with kexec. This is what we encounter, depending on the kernel of the distribution that is going to be booted, and also the kernel we provide in our boot image. So what we did is to offer a two-stage reboot. So again, we boot the UEFI, starts a shim signed by Microsoft with R keys. This grub starts with signed with R keys, kernel with R keys. And the machine prepares all the stuff. But again, this machine then downloads, creates a minimal boot partition, which again has our shim with our grub and the distribution kernel, which has then an overwritten signature by us. So the machine reboots into UEFI, it loads our key, loads our shim, signed by Microsoft, grub with our key, and the installer kernel with the overwritten signature. And after the next reboot, the machine is fine, and it starts with all the keys that are provided by the distribution itself. So what about the package distribution? We create our packages on the OpenSUSE build service, just for the ease, because they offer the infrastructure, and therefore we do not have to worry about creating packages for Red Hat, SLAS, OpenSUSE, and so on. There are currently no extra packages for the secure boot compatibility of Opsy. They are integrated into existing packages, mainly in the boot image package. And small modifications need to be done to support secure boot. As I showed you, the DHCP distinguished the difference between the identifiers the client sent. This has to be changed because the standard UEFI module of Opsy loads the ELILO, so it has to be changed to the shim, which chain loads the grub, and also the name pipe we create is a bit different from ELILO to grub. And currently, yeah, this is under co-funding. So, is secure boot a friend or an enemy? This, in my opinion, highly depends on your attitude towards Microsoft, because if you think Microsoft is a friend, I mean, Microsoft, it's not like, this isn't a completely black box automated process. They provide the infrastructure, but then again, they outsource the stuff to the Red Hat repository with people not working for Microsoft. So there are people working for other companies. For example, the guy that provided us the positive review works for Canonical, so he has no real benefit from allowing files or not allowing files to get signed. And in our case, this eases the process of distributing keys. Because if you would go to a customer which has, for example, 500 PCs, if you would have told him that, yeah, you need to distribute all the keys on your machine by hand, someone has to be physically in front of the machine, they would have thought that, yeah, you guys are crazy. No one would want to do this. And so, yeah, with this shim we provide, signed by Microsoft, we have no user interaction that is needed on the machines to provide secure boot support, and it saves a lot of time so you can work on other projects and can work with other stuff except for running from machine to machine to distribute all your keys. But this process has to be redone every time your certificate runs out. So, but now we know it takes at least 7 months. So we know, okay, within a couple of years we have to redo this, and not 1 month before the certificate runs out. So, but if Microsoft and the hardware vendor are your enemies, you are not depending on Microsoft. You can deploy your own keys, but this is connected with a lot of footwork. On the other side, you can lock out Microsoft out of your systems. You delete the key, import your keys. You can add, you can blacklist unwanted keys, so you can blacklist the Microsoft key, and only have operating systems installed that you want to have installed, not that are signed with a Microsoft key. Yeah. So thank you for your attention. That's my talk. Feel free to ask questions, and if you want to have a presentation of Opsy, we are still at booth 717 next to Ubuntu and KDE, OpenSUSE, for a live demo. Thank you very much. Yes?
So a year ago today, at this meeting, there was a talk called Network in a Zero Trust Environment with UEFI by OpenSUSE.
Okay.
And it was a very good talk. The abstract says, unfortunately, most network root infrastructure is based on outdated standards such as TFTP and PXE.
Yes.
So this talk said no one should use TFTP and PXE anymore, and it was about HTTPS.
Yes. I think this talk was also held last year by some guy from Intel, I think. So question was that TFTP and PXE are outdated, no one should use it.
So what about the HTTPS route? Have you considered that?
Yes, we are considering it. We are currently investigating in this. So we can ditch TFTP because HTTPS is way faster than TFTP. Yeah, so we are currently investigating it.
Are you working with the open system?
No, this is completely separately. But we use the documentation provided by OpenSUSE, mostly. Yes?
I was curious about, you say you script the signature of the kernel of the distro you want to boot, and then you add your own signature?
Yeah.
How do you verify that that object is the correct thing for you to be signing? Verify the signature that the distro you're installing uses?
So no, we override the signature with the standard tool provided to create or to sign files. And there's another component to verify the signature. So we then turn it around and verify that the signature on the kernel is correct according to our keys.
Right. I get that part. But how do you verify that what you're signing is the correct thing?
This is a good question. But the guy that gave us a positive review on the GitHub repository, he told us that, yeah, you should use an updated grub, because the grub we are using, which is the Ubuntu grub, in this version also allows non-secure boot stuff to be booted. But this is the thing we want, because we can't distinguish if it's secure boot if it's a standard UEFI client or a secure boot client. So therefore, it's okay for us to boot both without breaking something. So, but yeah, you're right. We are taking a binary from Ubuntu and can verify that this is legit. Yeah.
Another question. You were saying when you submitted the shim to Microsoft for
Yeah.
review, they went and reproduced the same shim
Yes.
in their own independent process?
Yes.
They came up with a bit-for-bit identical thing on both sides?
Pardon me?
And it came out bit-for-bit identical?
Yes. At least the checksum was the same.
Yes.
Yes. So we then got to Microsoft, told them, yeah, we got to. So what we had to provide is also the checksum and the file itself. So the guy could download the file, create the checksum of it, reproduce the file, and verify the checksum. And in our case, this worked out, so we were cool with it.
I worked on reproducible builds, so that's
Yeah, they asked for the operating system. The shim was created on various package versions. They wanted some specific, like what's the libc version and other packages. And they got the public part of the key. We got into the shim, so they had all they needed to reproduce the file. Yeah. Any other questions?
You did mention RV7 was the shim bootloader
No.
by Microsoft in that case as well?
No, I have mentioned ARMv7 because you can, if you have a Debian-based Raspberry image, you can also install Opsy on it. So we have one customer that is the administrator of a city council, and he has small offices, or in a kindergarten he has Opsy running, but now he's replacing it with Raspberry Pis because they are so small, and you don't need a real physical machine to do this.
And are they actually booting secure boot then?
They can provide the secure boot files, but the Raspberry Pi itself doesn't boot in secure boot. So the Opsy server itself doesn't have to boot in secure boot to provide secure boot.
The Opsy server is what's running on the client.
No, the Opsy server is running, it's the server that, yeah, it's providing the Pixie boot.
Okay, and so that is signed kernel and so forth.
It has the signed kernel, and it provides all the files to the client when the client needs them. So, but in the end, the Opsy server itself doesn't have to run in secure boot to provide all the secure boot files.
With the Raspberry Pi then, what is their
I don't know. No, because the Raspberry Pis don't support secure boot, I think. ARM devices that support secure boot, but as far as I know, secure boot can't be turned off on them. On regular laptop or desktop hardware, you can turn off secure boot, despite what Microsoft wanted initially. Microsoft didn't want people to turn off secure boot, but this was ditched by the UEFI committee. Any further questions? You're welcome. Thank you.
minus AV. Okay. Just blocking and seeing everything work. Okay. Could you check the battery on that one real quick?
Sure.
Yeah, you're good. Okay.
Great. Is there going to be somebody coming up to introduce me, or?
Because I've been going in and out. Okay.
Just get started. All right, good afternoon, Southern California Linux Expo. How many Southern California people do we have here? All right, lots of locals or near locals. How many California in general? All right. So this is going to be local for most of you. We're going to be talking about the California Consumer Privacy Act. Just another quick show of hands. How many have heard about the California Consumer Privacy Act? All right. So, January 1 of this year, a new law went into effect in the state of California. And if you can see fine print down at the bottom of this news site, it says, "Do not sell my data." If you click through, you usually get forms like this that says Privacy Manager. So what does Privacy Manager do? Is it just another boring set of information that companies have to give you, like the GDPR in Europe or whatever the other privacy law in California was that made everyone put a boilerplate privacy policy on their site? Is CCPA just a piece of paperwork that sites have to do? And so far, in a lot of cases, that's been it. CCPA, as a person in California, it gives you 3 basic rights. One is you can ask companies not to sell your information. Another is you can ask companies for access to your information. And finally, you can ask companies to delete your information. Now, of course, there are a lot of exceptions to these. When there's some other law that has requirements about your personal information, like the Fair Credit Reporting Act or HIPAA for your health information, then California Consumer Privacy Act probably doesn't apply to those. Has anyone tried to use any of your rights under CCPA? All right. All right, we're gonna go through some of those steps right now. But first, let's talk about it from the company side. If you're running a company and dealing with people in the state of California, even if you're not based in California, who has to comply? According to the law, any company with $25 million or more in annual revenue, 50,000 records of personal information, or company that earns half its revenue selling personal data, those are the companies that currently have to comply with CCPA. So that's the way it's written. In reality, the Attorney General's office in the state of California has about enough people and about enough budget to bring somewhere between 3 and 12 CCPA cases. So in reality, the companies that have to comply with CCPA is the top 3 creepy, famous companies in the state of California. So in practice, they're going to pick out some stalkerware, spouseware, spyware, some company that's listening to you on the microphone when they say they're not listening to you. They're going to make show of enforcement for those. But for now, we're not going to see a lot of enforcement coming down on regular companies. So go through the normal process and add the link to your site. It can just be an email link, and you're probably going to be fine on compliance. I am not a lawyer, if you have $25 million worth of other people's data, you can get a lawyer and they'll tell you the same thing. All right. So a little bit of history about how the CCPA came to be. It was originally a ballot proposition put forward by a prominent advocate named Alistair McTaggart. He agreed to withdraw his ballot proposition if the state legislature would put through roughly the same thing as a state law. So CCPA got passed, and wow, it's the law now. Everyone's going to start complying with it. Well, no. Everybody in the marketing business, advertising business, pretty much figured, well, Congress is going to pass some kind of a super basic minimal privacy law. They're going to preempt California, so we don't have to do CCPA. It's kind of like everybody was expecting there's going to be a school day. Everybody's expecting there's going to be a snow day from school, so nobody really did their homework. It turns out that Congress, because reasons, ended up not passing a federal privacy law last year. So on January 1st of this year, California Consumer Privacy Act actually went into effect. And what that meant is that everyone's implementation of CCPA on their website was real rough. So we ended up with the quick and dirty, how do we get minimal compliance with the CCPA working? And that is what we're seeing with the Interactive Advertising Bureau, IAB CCPA framework. Good news, real simple standard, real simple thing to observe and possibly change in your web browsing experience. So, any questions so far on background for CCPA? All right, great. I welcome questions during the talk, so please stick your hand up and I'll get to you. I can come down with the mic so that we can get questions onto the recording. So let me know. Yes, question. Hold on a second.
I was just going to suggest you mention what the IAB is.
Yes, IAB is the Interactive Advertising Bureau. And this is a really interesting organization. They started out representing the interests of the core players in internet advertising, right? The publishers and the people who really benefit from advertising one way or the other. And I'm trying to remember when this was, maybe about 10 years ago, they started letting the ad tech firms in. So now the IAB is this really, really weird organization because they've got on one side the publishers who benefit from particular high-value brand-building advertising activities. And then they've also got, somehow under the same tent, they've got all the ad tech vendors. So it's a constant tension between which kind of advertising this organization is really for, and it must be a huge, huge challenge for them to run. But they do come out with technical standards for complying with privacy laws like GDPR when that came out in Europe in May 2018, and then now for CCPA in the US. And it's funny that they're calling it US privacy because they're expecting there to be more state privacy laws. The one in Washington state looks really interesting. Anyone here from Washington? Okay. All right. So if you fire up your web browser and look in your JavaScript console, you can see that on a lot of publisher sites now, there's this thing called __USP API. And this is the US Privacy API that you can call from JavaScript. You can actually call it from any JavaScript on the page. You can call it from JavaScript in a web extension if you inject it into the page. So what I was actually hoping to be able to do for this talk is, hey, let's inject some JavaScript into the page. We'll flip all our CCPA bits to the right value, so we don't have to go through and click all those do not sell requests. I thought that would be awesome. I put it in for a talk for SCaLE, and since the deadline was quite a while ago before CCPA went into effect, I thought, yeah, I'm going to tweak these privacy bits. I'm going to show the awesome privacy experience. And what I'm going to get into now is why I ended up pulling on a piece of a much harder problem than I thought I was pulling on. All right, so you call USP API from JavaScript, and this is my code here, calling USP API. This is based on their example code. And I say, get USP data, and then of course I give it a JavaScript callback, and so I can get back my USP data, or if I don't get that success bit coming back from my USP API, then I can say US privacy fail. And what I get back from USP API is version 1, USP string 1YNN. Okay. Anyone familiar with the transparency and consent framework for GDPR in Europe? That's the European version of this is designed to comply with the European GDPR, and their consent strings are way longer because they've got a lot more legal requirements that were a lot better spec'd out. This is a super simple string, and we can interpret it pretty easily. In the IAB's US privacy string, the number 1 is just a version. This is version 1. Has explicit notice been provided? So has the site on which this USP API appeared given me some notice of my California rights? And in this case, they're claiming, yes, we notified you of your California rights. Number 3, has the user opted out of sale of personal information? No, I haven't opted out. And number 4, publisher is a signatory to the IAB Limited Service Publisher Agreement, and the publisher declares the transaction is covered as a covered opt-out transaction or a non-opt-out transaction as those terms are defined in the agreement. Now, this is an agreement that a model agreement that the IAB is trying to push through to try to weasel out of some of the requirements of the CCPA, and it's still an open question among privacy lawyers as to what even, quote, sale means under CCPA. So this is going to take a while to sort out. The big problem here, as I originally saw it last fall before CCPA actually went into effect, big problem here is that letter N has the user opted out. It all looks good, except I want to make a Y there. So, and this is basically what I intended to do with this talk, is, hey, I'll make my own USP API, right? I'll inject that into the page in my web extension. I'll come back with not 1YNN, I'll come back with 1YYN, and I tell every piece of third-party JavaScript code on this page that's checking US privacy, I tell every third-party tracker, yes, I'm opted out. I am one of the rare Californians who's actually gone through and clicked, do not sell my personal information, only I get JavaScript code to do that for free. So I thought that was a pretty good idea. So yes, let me bring you the mic.
Wouldn't it be a lot easier just to go to the IAB and opt out?
If I go to the IAB and opt out, there are sites that pretend to offer a cross ad tech opt out, right? Like my privacy choices, the little arrow thing at the upper right corner of web ads where you can click through and hit the multi ad tech vendor site that does opt-outs. The problem with that thing is they've got like 100-some companies participating, and there are over 1,000 third-party trackers that you regularly run into on the top million sites that you visit. So realistically, you can hit a cross-industry opt-out, and even if you're running something that preserves that opt-out across your third-party cookies getting deleted, you're still not going to hit as many of the third parties as you need to hit to actually get opt-out. Does that answer the question?
Well, assuming that they're all using the US, I'll just speak.
Yeah, okay.
Repeat the question.
Yeah.
Assuming that these websites are calling USP API,
Yes?
right? They have to get that code from some place. And ideally that would be the IAB.
Right, but they're calling a USP API that lives on the page. So the IAB standard says that USP API has to be there in advance of those third parties. So it would be, I think I can figure out how it would be better to be designed the way you're describing it, but the way it's actually designed is that they make the publishers stick this USP API onto the page early on. So this is JavaScript on the page that's letting all the third parties know whether or not the user in this session is opted out or not.
Right, but, okay, so I'm going to take this one step further, which is if you actually have not opted out, an active click, when you say, yes, I've opted out here, you actually haven't done it. And so is that legally enforceable at that point? And I'm just picking holes in your scheme of trying to get around this. But I agree. Selecting opt-out is probably the thing you want to do. But legally, if you don't actively click opt-out and you're just saying, yeah, I signed the contract. Signed the contract, right.
Yeah, that's a good point that is specifically addressed in the regulations that the Attorney General's office has put forward on CCPA. And so the Attorney General's regulations say that if the user has made some kind of a setting in their browser by user choice, then that has to be respected as a do not sell signal. So if a browser just shipped code that overwrote USP API for all the users, then that would probably be a problem because it's not a clear indication of the user's preference. But if the user deliberately turns on some kind of a privacy tool to override USP API, then the Attorney General says you must respect that. All right, so this looks cool. This was going to be my JavaScript talk, and at this point I was going to bring up a web browser and say, hey, check it out, we're all in privacy mode, we're all safe, we're all good. And then we could have turned into a discussion of the finer points of JavaScript, building a web extension for multiple browsers, all that kind of fun stuff that would have gone over really well at scale, but unfortunately, here's a web ad. Now, the advertising you see when you go to almost any website now that has advertising on it, that advertising is the result of a real-time auction. And in that auction, different ad campaigns bid for the slot to reach you. So, you might be looking at a My Little Pony site, and you see an ad for a Lexus, because there's some third-party tracker that has seen you also went to Car and Driver. So every ad that comes up is the result of a lot of code from a lot of different players deciding how much money do I want to spend to get in front of this person. The problem, if you decide to become a privacy nerd, is you start getting ads like this. The problem with saying, don't use my personal information, is, guess what? There's a lot of people out there who are willing to share their personal information. And the ad campaigns that spend money on professionally shot photos and professional layout are also spending money to bid to get in front of desirable audiences. If they see they don't have the right to figure out if I'm a member of one of those audiences, then that professionally shot photo of a Lexus driving down a scenic highway that I might have gotten and not so much objected to, that campaign doesn't show up for me. What I do get is super cheap ads. And I'd like to point this one out to you because it's one of, it's a good example of what they call ad arbitrage. See who the advertiser is? Yahoo. The advertiser for this ad is Yahoo Search. But this is a display ad. This is a square ad that shows up on an article. So what's going on here is Yahoo is selling search ads, which of course get a lot of money per click. And then they're getting a lot of traffic to those search results pages by placing display ads. Now this arbitrage model only works if they can buy low and sell high. In this case, they're selling high because they've got some advertisers buying keywords related to Crohn's disease. It's a medical search. It's something where they can sell the miracle colloidal silver solution that's going to cure Crohn's disease and whoever knows what else. Those advertisers are making big money. They're bidding high. They're giving Yahoo a lot of money to show up on that search results page. So Yahoo can turn around and buy display ads. Where do those display ads go up? Where do those display ads show up? Those display ads show up for random people who are opted out of seeing the higher quality ads. Here's an Outbrain opt-out page. And when I was looking at this, I realized, hey, wait a minute. I run Firefox. I run the cookie auto-delete web extension, I'm already not getting tracked by Outbrain. I don't need to go opt out of Outbrain because my technology already handles it. So the best place for me to deal with privacy problems is just something that works by default in the browser. I don't have to worry about it at all. Second best is it's something that I install as a browser extension. And then third best is something I have to do manually. In the case of Outbrain, it's already handled by Firefox. I don't have to worry about it. So I shouldn't be wasting my valuable time on opt-outs that affect things I'm already protected from. So where do I need to focus my CCPA do not sell access and deletion requests? Where I do need to focus is people who have information on me that I can't influence in the page, in the browser. Credit reporting agencies. You can do CCPA opt-outs on the marketing side of credit reporting agencies without dealing with your actual credit report. These have a huge amount of data. They're a high impact place to opt out of. Creepy data brokers. These, you probably haven't heard of them, but I will show you in a few minutes how to find them and opt out of them. Axiom, Epsilon, LiveRamp, Oracle Data Cloud. Finally, any company that might have sensitive info on you, particular brands that you might have had a customer service relationship with where you share some sensitive aspect of your family life or your personal habits. And then any company where you're actually using their single sign-on, if you're clicking sign in with example.com, those, you want to get them with the do not sell, obviously, but you can't really get them to delete your information because you still want the single sign-on to work. Now, who wasn't on that list? Facebook. And if you get one thing out of this talk, I'd like you to think about the hashtag #unDeleteFacebook. Because, for now, getting back into your old Facebook account, if you still have one, is the best way to spot companies that are doing privacy intrusive practices on you. This is just for now, given the status of what you have access to in Facebook today. Of course, it could change. The other reason why you don't want to worry about doing opt-outs with Facebook is right now, Facebook management has asserted they don't really have to follow CCPA, so you'd be buying yourself more of a beef than the actual impact at this point.
Why don't they think that?
Because they have very expensive lawyers, and the California Attorney General's office is understaffed for this stuff.
Let's never stop government from bringing action.
Well, at the second to last slide, I'll have an update on what's going on with that. Okay, who has gone in and looked at your Facebook information or your Facebook ad settings? Okay. This is buried treasure. Not because Facebook will do anything if you click on anything here. Consider this a pure read-only medium, but this is your main CCPA intelligence gathering tool in a lot of cases. Your off-Facebook activity, also known as companies that chose to send your personal information to the world's creepiest PHP programmer for some reason. In my case, Office Depot. I bought a case of printer paper from Office Depot. The very next business day, they show up in off-Facebook activity. Office Depot ratted me out to Facebook. Microsoft CDC and Airbnb, I didn't really do business with either real Microsoft or real Airbnb. So those are probably just scam companies using a real brand, but the Office Depot one was likely real. So Office Depot now presents itself as a high concern place where I need to get my CCPA opt-outs done. Okay, there's another Facebook page which is under advertising, and if you click on businesses under advertising, you will see LiveRamp. LiveRamp is a big data broker. They have a lot of information on a lot of people. You will also see companies that you actually do business with. In my case, there's United. There's another data broker, Axiom. And Waste Shaper Company? Nope. They have no reason to actually have my personal info. Steelhouse? No, they have no reason to have my personal info. Some of these companies are companies that actually have my personal information because I actually did business with them. Some of them are data brokers that got my information some other way. And some of them probably just found an old spam CD behind the file cabinet. There's no way of telling where these companies got my information. But just to keep an open mind on Facebook and drill down into, especially your off-Facebook activity, you'll find companies that have leaked your information. And if they're leaking it to Facebook, they're going to leak it to other places. All right, so I just showed you a slide that included United Airlines, and last I checked, United did not even have their CCPA button or Do Not Sell link installed on their homepage. So if you want to do an opt-out and sites don't have a CCPA button, well, according to the regulations, if a consumer submits a request in a manner that is not one of the designated methods of submission, basically, if you send in your request in the wrong method, they have to come back and tell you what the right method is or honor it anyway. So what I've found is that by sending an email to their privacy contact email address, I can generally kick off a pretty fast, pretty productive CCPA process. The catch, though, is sending that hash object does is take my CCPA letter, hash it, and stick it into the X header. So it's really easy for me to keep track of which versions of my CCPA letter I sent to which companies. So that's the headers, and now chop off the front matter from my boilerplate letter, and now I'm going to run mutt with the option of not using my regular signature, because I don't want to confuse them. I just want to give them a straightforward letter of what I'm demanding that they do under CCPA. I'm going to run mutt, no signature, -h temp file is I'm using that temp file as my outgoing mail. And so I can look at it in mutt, and I can add CCs, or I can change the letter around a little bit. But normally what I just do is ccpaexample.com, the letter comes up in mutt, and I just send it out from mutt. Super fast. You can CCPA a company just as fast as you can cut and paste their email address. But there's still a problem. There's still a problem that as a person who puts a lot of time and effort into privacy stuff, I'm not helping myself all that much for the amount of work that I put in. If we were all getting as much out of privacy work as we put into it, well, then there'd be a lot more privacy work going on. People have done some really positive steps in let's get me protected. And we've seen that with browser protection tools like Apple Safari's ITP, Firefox ETP, now Microsoft Edge has tracking protection, Google Chrome's finally going to do it. We've seen a lot of positive progress on the technical side, but we're really putting in a lot more effort than we're getting out of it. We're kind of paving over or painting over a problem rather than trying to attack it upstream. And usually in open source, you want to work upstream. You want to figure out where is all this problem coming from? How can I make things work better for everybody rather than constant rain of new surveillance marketing crap and constant churning of trying to opt out of it? So if we want to think about where the money comes from, of course it comes from marketing budgets. And marketing budgets are allocated across paying for context, which can be, in a typical example, some kind of ad-supported news or cultural work. It can be some kind of a resource like a bus bench. Marketing money also goes to support services like search and directory services. And finally, some marketing money goes into supporting surveillance and targeting. And it's not a pure split. Of course, some campaigns will allocate a certain amount of money toward paying for context. Some of it is spent in paying for audience data. So it's a mix. But fundamentally, ad money is split across those three places. And ad-supported news and culture, the money that went into Collier's magazine advertising back when Kurt Vonnegut was writing short stories, well, that money has positive externalities even today. Those stories are still out there. All the Star Trek episodes that were paid for by TV advertisers in the 60s are still out there. So there's positive externalities of ad-supported content. And ad-supported content carries an economic signal. It shows that the advertiser is willing to pay money to invest in promoting their brand. I want more ad-supported content. Search and directory services, of course, those are positive sum. I like Google Maps as much as anybody. We were just walking from the convention center, or walking from the hotel to the convention center, and we decided, hey, we want to get brunch. We did a search, we found a great place, we got some food. Search and directory services are awesome, and I'm happy that marketing money pays for them. Targeting, on the other hand, targeting has all negative externalities, and it's a negative-sum game. Every time my name is in some marketing database somewhere, I'm taking some risks of a data breach. I'm taking the risk that my information is going to be used for political information. And, of course, I'm taking the risk that money that could have been spent on content or services for me is going to some data broker who has my information. It's a big lose when my information's out there, but marketers won't reallocate across those 3 ways to spend ad money until they see more people protected. Protection is not just something that you do for yourself. Protection from surveillance marketing, from targeting, is a public good. And public goods are underproduced. We don't have the market design in place to incentivize people to produce as much of public goods as we would choose for them to produce. And the result of underproduction of this public good, of privacy protection, is we're facing crappy ads and security risks. We want users to get a better deal. We want publishers to get more money to support content. And we want to reduce the malware impact on users. Malware is conveyed through third-party tracking. And we want to address some of the political concerns around targeting. But we saw that each individual opt-out, or each individual privacy protection step, is a very small thing for an individual to do. Anybody recognize this plant? Okay. This is a plant called Arabidopsis thaliana. And the fun thing about this plant is it's small, it's cute, it grows fast, it's easy to raise in a greenhouse. You can do all kinds of fun science on this thing that later applies to crop plants. So you don't have to have a cornfield, a wheat field. You can do agricultural research and botany research on these little plants, and then later apply that to the big complicated fields. So our CCPA opt-outs are like the Arabidopsis thaliana of public goods. It's something where we can experiment with how do we get people opted out. And the question of how do we get people opted out is related to the question of how do we get people to participate in creating any public good anywhere. It's a laboratory. And we can address the problem anywhere along the surveillance marketing kill chain. The process of surveillance marketing has to hang together across multiple steps. They have to identify who you are. They have to, thanks to GDPR and CCPA, they have to check that they have the legal right to use your information. They have to deliver some kind of a payload, ad, call to action, whatever you want to call it, email, spam, malware. They have to deliver the payload, and they have to attribute the results. They have to know that the surveillance targeting thing that they did was effective. You break the surveillance marketing kill chain anywhere along the line, and you've disincentivized investment into that category of marketing. So how do we do this? Well, can we apply market mechanisms? Here's a novel market design for trading futures contracts based on bugs in a bug tracker. Oh, can we gamify it? Here's a game called California Privacy Wizard, where you do opt-outs, and each opt-out you do gets you new spells that you can use to have wizard duels against other players. But all these methods that we might try for getting people to opt out, don't we still have the inexorable force of all the capital in the world bearing down on people's privacy? Isn't there huge amounts of money being invested in surveillance marketing? Is surveillance marketing a dystopia, the Terminator? Personally, I don't think so. Marketing budgets and venture capital investments are subject to fads. When the Digital Millennium Copyright Act came out, a bunch of companies that were pitching for investments to venture capitalists stopped getting their calls returned. Why? Because those venture capitalists were deterred from investing in anything related to media sharing, home jukebox, home media network. All that stuff is blocked off by the DMCA's more market power for the copyright holder, less market power for the device manufacturer. So there's a time lag between investment in privacy and shift in marketing spend. And we can move marketing money out of surveillance by creating those incentives to participate in public goods. And this is the answer to what's coming next. This is the latest California Privacy Rights and Enforcement Act of 2020, also known as CCPA 2.0. This will give the people of California a new privacy enforcement agency that gets a new budget, semi-independent of the Attorney General, so they get to bring more cases and do more stuff. The question for technologists now is, this is the trend, how can we take advantage of it, and how can we learn from privacy to build more public goods in the future? And there's my Creative Commons photo credit, and any questions?
So there's some people who famously, like Leo Laporte, say ads are good. I want ads that are relevant to me. I want to know about these products. I'm getting free stuff from these companies, free services. And he's somebody who, and he and others are people who normally admonish anything that looks devious in the tech industry. So how do you explain that sort of bipolar view of the world and its impact on CCPA and other regulations?
I'm glad you asked. The question is, some people really like ads, and I have to say I am one of the last few advertising optimists out there as well. I was at one conference on the future of business models for journalism, and a bunch of business models were brought up: subscriptions, events, merchandising, apparel, cosmetics. How many speakers were talking about advertising as a way to fund the future of journalism? This guy. What is it about the way we structure advertising today that makes it so terrible for supporting journalism and public goods? What is it that made magazines on print able to pay writers more than they're getting now on the web? How's technology pushed advertising backward so far? Advertising business models worked better when they were designed by people who were breathing fumes from molten lead all day. So there's a tremendous amount of potential in advertising as a way to support content. We are letting most of that money waste away and go support targeting and privacy intrusion, when we should be able to redirect it back to support ad-supported services and ad-supported content. All right, yes?
Never going to happen.
Never going to happen. Okay.
Well, ATP already does that.
Okay, hold on a second. Let's get somebody new.
Oh, I was just going to say that the ATP podcast already sells their own ads. They don't require selling any of their users' data. So it can happen.
Yes, it can happen. There are pure contextual targeted ads. There are ads that are targeted based on permission-based subscriber lists by individual publishers. So we're seeing right now a lot of publishers saying, well, what are we going to do now that Chrome is killing the third-party cookie? Well, that's kind of a 2-year window and invitation to experiment with new models and with taking some of the ad systems that have been really successful in podcasting and applying those to other media.
The marketers like the targeting because it gives them metrics that they don't otherwise get from contextual marketing. It's just intoxicating to them, I think. I think that's just, it's really, really motivating.
Yep, that's true. That's true. Every marketing department, and I've worked in marketing departments, every marketing department has exactly 2 jobs. One of them, sell stuff to customers. The other job, sell marketing to companies' management. Now, if you're putting up those numbers that directly attribute sales to particular marketing activities, that makes that second job a hell of a lot easier. So part of the challenge here is looking at some of our niche audiences where there are a lot of privacy nerds already, and say, hey, I used to work for a NoSQL database company, and 60% of the people there were invisible to Google Analytics even. So if you have a niche that's highly populated with privacy nerds, how do you reach that niche? And especially in a valuable niche like DevOps, what can you do? And then once you've got that niche, how do you build out from it? Yeah, just a minute.
It seems to me that if you're trying to reach people that are trying to be off the grid, you want to reach their influencers. And so, like he's talking about Leo Laporte being a possible influencer, is you'd have to get other influencers on board with your point of view and get them to broadcast it for you. And hopefully the people that are listening to them that would be otherwise unreachable.
Yes, exactly. And that's why we have kind of an informal network of people at ad agencies, at publishers and publisher organizations, and brands that are thinking about this problem and thinking about privacy as not just, oh no, where's all my user data going to go and how am I going to show my ad spend works, but thinking about how to redesign some of those market mechanisms. And I hate to say it because it's a big company that does targeting, but a lot of that discussion is actively happening on Twitter. So if you follow me on there and check my Twitter list for brand advertising online, There are a lot of people who are making some really, really interesting progress in this area. More questions? All right, well, thank you all for coming out, and please come see me at the rest of the event if you have any more questions that occur to you, and thanks again.
Okay, I think we can get started. Hello, my name is Simon Elmire. I'm a production engineer with the artificial intelligence team at Facebook. That means we keep the AI systems up and running and healthy. So I'm going to give a talk a lot about being more efficient and productive on the command line. This talk is based on a series of internal talks that we provide optionally to employees at Facebook, and a couple bits of context about the onboarding process at Facebook that will help illustrate some of the things that we'll be talking about a little bit later on. All of the engineers at Facebook go through a boot camp. So this is a few weeks at the beginning of your working at the company, where you're just learning how to use Facebook systems, a little bit about our culture, and about the tools and techniques that you'll need to do your job. For engineers, especially infrastructure engineers like myself, who do a lot of work on systems and a lot of coding, we have development servers that are outside of the office. So our development servers are in the data center, and we connect remotely to them to do our work. Efficiency, especially on the command line, I want to cover three things. Efficiency is about, number one, being faster. If there's something that you're doing that's taking a lot of time, especially if it's tedious or repetitive, then that's probably something that the computer is going to be better at doing than you are. So if you find something that you're really annoyed about, like you're just running the same command again and again with a slight variation, try and get the computer to do that for you. We'll talk a lot about using history a bit better. So this is to help reduce mistakes. Like if you've done something more than once, you've created some complex arcane command that did exactly what you wanted. You want to be able to get to that again later on so that you can reuse it later. And since you've gotten it correct in your first iteration, you're much less likely to make a mistake if you're just retrieving it from your history afterwards. And also, efficiency is about health. One of the engineers who created this class at Facebook had problems with carpal tunnel syndrome and repetitive stress injury. His doctor advised him that he should avoid typing for 6 weeks. And for an engineer whose day job is to code and type, that's not great. So we'll cover a few different areas where we can be more efficient. Don't feel like you have to use all of the tips and tricks that we're going to talk about in the class. Pick as many as you like, as few as you like. If you find customizations that work better for you, it's perfectly fine to disagree with me about all of these things. It's just about presenting what you might find useful. So we connect to a lot of remote servers at Facebook. And one of the first things that we recommend to engineers is to use an alternative to basic SSH. So I have in my shell over here, I'm connected to a remote server. If I'm running some super important command on this remote server, so super important command, and then I go and do something silly like, I don't know, suspend my laptop. Normally, with a regular SSH connection, breaking that network connection between you as the client and the server actually hosting your application on the remote side would be killed. Like if you're running a text editor, it would kill your text editor, for example. I'm going to do something like this. I've just turned off the Wi-Fi on my laptop, and since I'm using Mosh instead of SSH, it gives me this convenient message at the top of the screen. Mosh is complaining that the network is unreachable and that it's been a little time has passed since the last communication between my laptop and the server. If I were to suspend my laptop and connect to a different network, that would certainly break a conventional SSH connection. But if I turn on my Wi-Fi, it'll take a few seconds to reconnect. But what Mosh is going to do is it's going to automatically reestablish the connection, even if the IP address of my laptop or even the network of my laptop has changed significantly. So we've reconnected to Wi-Fi, and now my application continues to run. I've automatically reconnected. I don't need to re-authenticate. Mosh is taking care of that all in the background for me. So how you would do this, Mosh is essentially a drop-in replacement for SSH. It's available in many of the standard repositories for many Linux and Unix distributions. It takes much of the same syntax as SSH. So here I'm just running Mosh, and I'm logging into my machine at example.com. Type in my password. I'm now connected with Mosh. and now this connection is resilient against interruptions on the network. Mosh is also especially good when network quality is very poor. So if you are on a train or on a shuttle and you're tethering to your phone, desperate to fix some issue on a production service, the quality of your connection, you don't want to like risk a command that you're running dying or being killed because you've lost connectivity. Mosh is extremely good at resuming connections, and it has buffering both on the remote side and on the local side, so that like CMatrix runs an animation, I didn't have to watch the remainder of that animation play out in full during the time that I was disconnected. It just shows me the latest data, the most recent frames, and if I'm watching a log or I print out too much data, I can hit Control-C to like cancel or kill that process, and Mosh will make sure that that connection goes through. In addition to Mosh, we have another utility. It's less common in package repos, but it's Eternal Terminal. It's similar to Mosh. Like Mosh is a little bit better at poor quality network connectivity, but Eternal Terminal has a richer feature set while still providing that resiliency against network dropouts. So Eternal Terminal supports things like X11 forwarding, port forwarding, where Mosh doesn't. But what if you've connected to a remote machine and maybe you want to maybe you're connected to a remote machine on your desktop at work, and you'd like to connect to it on your laptop when you're at home. If you have a single connection using Mosh, for example, you're going to be connected to like a different session when you're on a different machine. So on my local instance here, we have a set of utilities which allow you to reuse a connection and to split a single connection into multiple applications running on the remote server. The traditional applications for doing this are Tmux and Screen. Both of these utilities have been around for a very long time. I personally prefer to use a wrapper around those called Byobu, which is the Japanese word for folding screen. So what Byobu is going to do is it's going to launch Tmux with my favorite configuration. And now I can control the remote session that I'm logged into in a number of interesting ways. Every command that you send to, in this case, Tmux, is going to at first be triggered by a special keyboard combination. So the bind key, by default in Tmux, it's Control-B. When you first launch Byobu, it's going to ask you whether you prefer Control-B or Control-A. Because of some of the shortcuts later on in the slides, I personally recommend Control-B to use as the bind key. But you would press the bind key followed by one of the other keyboard shortcuts on the slide. So if I press Control-B and then I type a C, what that's going to do is it's going to create a new window inside this connection. So I just hit that keyboard combination, and now I have, you can see in the bottom left corner of the display, I have session 0 and session 1. Anything that I run in one session, I can then toggle back and forth between my windows. So the next shortcut on the slide, so I'd hit bind key and then N and bind key or P to tab between each of the sessions that are currently running. So I have one terminal currently running CMatrix. If I hit bind key N, then I get to see my other session. Maybe I want to run top. I hit the bind key and C. I create another session. So now I have 3 things running on this server at the same time. I've only authenticated to the server once. I only have one network connection active, but the server is going to keep this state for me. I've mentioned that you can use this with multiple different machines. So I can disconnect from a Tmux session. Bind key D will disconnect me from that session. And if I ever want to reconnect and resume that session, like I still have applications running on that remote server, I would just run Byobu again, and it resumes exactly where I had left off, where I have my session of top and my session of CMatrix still running. This is very useful if you have, you want to like switch from your desktop to your laptop. I've fixed things in production even on my cell phone. Like I've already had a Byobu session running on my development server. I've logged into it from my cell phone. I've already got all the utilities sort of running and monitoring what I like to monitor, and so it's very convenient. It's worth mentioning that the bind key followed by a question mark will give you the documentation for all of the different bindings that are currently configured in your terminal emulator, in your terminal multiplexer. So this is the full list of documentation. You can check out the man page for Byobu or the man page for Tmux for a lot more details. The site for Byobu is in the QR code on the display. So history. By default, Bash keeps a listing of all of the commands that you've recently typed. I'm going to print out the last few commands that I've run. Some of these are pretty obscure and obtuse, but this sed command, for example, this is something that I wouldn't want to have to remember and wouldn't want to have to reference, because this is a very complicated regular expression. So if I wanted to rediscover, like, how did I do that regular expression, there are two things that I did to make this easier for myself. One of them is you can just hit up repeatedly. This is part of the default configuration. So pressing up repeatedly will give you commands that you've recently typed, and I can get back to this sed command that I mentioned. There are easier ways of doing that, however. So if I type Control-R, this is going to give me reverse incremental search, which means anything that I type, it will show me the most recent command that contains that string. So if I type S, I'm going to get something having to do with history. If I type E, as in SE, then it finds, oh, something in my previous history contained S and E next to each other, which is my sed example. But I've done something even more to give myself a better chance of finding this command, and that is I put a comment at the end of the line. So let me just find this in my history again. So anything after the hash mark in Bash is a comment. Because I know I'm going to want to reference this command again later, I just put a comment at the end of the line. It's my sed example. So if I want to find it again, I can just reverse search for sed example. And as I'm typing it, it will find that because it's in the comment. That doesn't change the behavior of the command, but it makes my own personal history a little bit self-documenting. You can, if you have multiple commands that match, like you have multiple sed examples, like I run sed somewhat frequently, so I'm going to type sed, and if I press Control-R again, it will rerun the search with the same string. It'll just go further back in my history. So sed appears twice on this line, so it highlighted the other sed. Here's another sed command that I ran, and if I keep pressing Control-R, it would keep giving me results from my history that contain that string. If I've accidentally gone too far, like I want to get back to my sed example, which is newer than this in my history, I can hit Control-S a couple times, and that's forward incremental search, but with a huge asterisk, which I will talk about on the slide having to do with STTY. Another one of the really nice shortcuts for searching through history is the Alt-Dot, which is yank last argument. So if you, for example, I don't know, touch, I'm just going to create an empty file here. I'm going to make a directory, example. I'm going to move that because I didn't quite name that what I wanted it to be. Example foo.sh is a better name for it. And now I want to cd into this example directory. Maybe this path is really long. I don't want to have to type that out by hand all over again. Alt-Dot is going to be a really convenient shortcut for me. So I'm going to hit cd space. That's the command that I intend to run. I'm going to press Alt-Dot, and what it's going to do is it's going to cycle through all of the last arguments of each of the commands that I've recently run. So first it's going to show me example/foo.sh. That's not exactly what I want. And then it's going to show me foo, and then it's going to show me example. And example is the one that I want. So I'm going to press Alt-Dot, Alt-Dot, Alt. Oh, no. So yeah, ignore that one. That wasn't actually a command that I ran. So it showed me cd example. And then I didn't have to type the path all over again because it was the last argument in something that I recently ran. So maybe you're editing a file and you want to later like run that file. So if you were to open this in an editor, like foo.sh, and now this is there's something in it like that. And if I want to run that file, maybe I don't want to type the whole file name all over again. I could just, for example, bash bash alt dot, and it would fill in the last argument from my previous command, which is the file that I had just edited. In addition to just being able to crawl through history, for example, the history command prints your entire history recorded on your machine, it's very useful to preserve even more of your history. The defaults for a lot of these configurations came from a time in computing where storage was extremely limited. Plain text, especially on modern machines, you can fit many, many thousands or millions of lines of history on a fairly low-powered machine these days. So we do recommend, and these slides will be uploaded to the SCaLE website. So if you look at my talk on the SCaLE website, you can download the slides, so you don't have to manually copy the text out of these. But if you were to put this in the .bashrc file in your home directory, it's going to do two things. One is it's going to change the location of your history file to this bash history actual. That gives us a little bit of insurance in case your personal configuration is only partially applied, then we're not going to clobber all of your carefully curated history. And it's also going to change the size of the history. So instead of the default, which is just a few thousand lines of history, we're going to store, this is what, like 1 million lines, and we're not going to impose any limit on the total size of the file. Oh, and a third thing that we're doing here, so prompt command is a special variable in bash. It's going to run whatever is set inside of prompt command every time it shows you your prompt. So I'm running two things. I'm running history-a, which will immediately save the history from my current buffer. And then I'm going to run whatever else was configured as the prompt command. It's important to note the history-a here. If you're running a bash session, the commands that you've typed aren't immediately saved into your history file. In order to get that to happen, you either need to exit bash gracefully with Control-D or with the exit command or by logging out normally, or you can run history-a. So history-a here as part of the prompt command is extra insurance that any commands that you've recently run are going to be saved to history, even if your session dies or bash quits unexpectedly or the server crashes and bash didn't have a chance to exit successfully. And then finally, we're just telling bash to, whenever you write history, just always write it to the end of the file. That helps keep things chronological in the history file. In addition to the commands that you run, it's also worthwhile to keep the history of the output of those commands. So I'm using tmux primarily as my terminal command. So let me run so here I'm going to print out the numbers 1 through 1000. I'm going to print out an important string, and then I'm going to print out the numbers 1 through 1000 again. This is just an artificial example. Like you're scrolling through the output of a program, it dumps an awful lot of output, and you saw something flash by briefly that was really important to you. So in your own terminal, you want to be able to scroll through as much history as possible. 2,000 lines might seem like a lot, but in terms of the amount of memory and storage that's required, loading a reasonably complex web page on a web browser is going to be orders of magnitude more data than just adding like hundreds of thousands of lines of scrollback history. So as I scroll backwards with my mouse wheel in this case, I can find, oh, there is the important string right in the middle of my scrollback history. This is going to be configured in one of two places or in both of the two places. Number one, it's going to be in whatever terminal multiplexer you're using if you are using a terminal multiplexer. So in the case of vanilla tmux, it's just .tmux.conf in your home directory. Or in the case of byobu, it's going to be in the .byobu directory and then in the file profile.tmux. So that's the command you would add to that file in tmux to configure it. Or if you're not using a terminal multiplexer, then look in the configuration options for whatever terminal you're using that's part of your operating system. So in iTerm and PuTTY, I'm using console on some of my Linux machines. It'll be in the configuration options there. Let's dive a bit more into some of the shortcuts. There are a couple layers of shortcuts that are accessible when you're using a standard terminal connection. The first layer that gets in line is STTY. This controls the actual serial port, like virtual serial port connection that's established when you have like SSH or a terminal emulator up and running. Probably the most convenient shortcut is Control-C. If you're running a command like sleep infinity, and you decide you don't want to run that command anymore because, in fact, this one will never exit, you can hit Control-C, it'll kill that command, and, well, more precisely, it'll interrupt that command, and then that command will try and exit gracefully. If a program needs a little bit more convincing in order to exit, we have another signal that we can send. Control / sends a sig quit. Control / is going to quit, and you'll also notice that it dumped a core. This is a snapshot of the memory of that application. So you see that this is saved somewhere in particular on the system. So if you needed to debug it later, you can check out the snapshot of memory in a debugger. Control-Z suspends an application. So if I didn't want to quite kill this sleeping for infinity, I can hit Control-Z, and we'll talk about job control a little bit later. So I'm going to kill that in the meantime. Control-S and Control-Q start and stop the actual serial connection. This is about like rate control in a serial connection. I don't find these to be useful at all in modern day terminals. They exist for historical reasons, but the important mention here is that Control-S conflicts with the history searching from a few slides ago. So Control-S is that forward searching, which is similar to Control-R, but STTY is going to get in the way first. And in order to prevent that STTY from getting in the way, we recommend that STTY-IXON be added to bash RC. That'll disable the functionality for this Control-S, Control-Q stopping and starting of the actual terminal serial connection itself. So after the communication happens inside the serial terminal connection, then we have readline. So readline is a library that's used by lots of different utilities. Bash uses it for the actual text interface as you're typing commands. So does, for example, the MySQL client. So as you're typing a SQL command in the MySQL CLI, it also uses readline in order to accept input from the user. There's a whole series of shortcuts that are available for readline. A great number of them are inspired by the shortcuts that are available in the Emacs text editor. There is a mode for readline that you can enable in its configuration to make it behave more like VI or Vim. Check out the man page if you're interested in doing that. But in general, since I work with a lot of machines that I don't personally control, I find I like to use the default shortcuts. The first shortcut on this list is my absolute favorite. It's the undo button. So say, for example, I had this sed example, this sed command, and I pressed backspace. I'm trying to erase my comment, and oh no, I've just erased too much. I didn't mean to do that. I need to undo. So Control-Shift-, that is, I'm typing a control underscore. That's going to undo whatever recent change that I've made to the text of the command. So I can hit that just a few times, and there we go. That's as much as I wanted to actually delete. I find the undo button to be so convenient and yet so obscure. People have been working with, I know people who have been working on the shell and on the command line for over a decade who have never encountered it because it's actually pretty hard to discover these if you don't already know like where the documentation for them is. So we have a few additional shortcuts that I like to highlight. Control-W and Alt-Backspace have to do with erasing whole words at a time. So in this sed example, instead of like holding down the backspace key to erase just a few characters at a time, I can hit Control-W a few times, and what it's going to do is it's going to erase the text one word at a time. So Control-W erases example, Control-W erases sed, and Control-W erases that hash and the space. Control-W again erased that entire text string. Alt-Backspace behaves very similarly, but it considers different characters to be parts of words. So here, if I press Control-W, it's going to erase everything that's part of this regular expression, including the apostrophe that starts out the quoting part. But if I press Alt-Backspace instead, it's going to erase a portion of the regular expression, and if I press it again, it'll erase another portion of the regular expression. So it uses different characters to delimit words. Okay, so I have to keep the text editor near the top of the screen so that everyone can see what's going on through the heads of the crowd. Thank you for the feedback. Cool. So here, Control W erases words at a time, and Control W again will erase my entire regular expression. And then undoing that and using Alt backspace instead, I'm going to erase the G apostrophe, and then I'm going to erase everything up to the next apostrophe. So it uses a different separator for each of the instances of either Control W or Alt backspace. Control A and Control E jump to the beginning of the line and the end of the line respectively. If you don't feel like using the home and end keys on your keyboard because they're relatively far away from where your hands are laying naturally in a typing position, you can use Control A and Control E to more easily get to the beginning or the end of the line. And there are analogous shortcuts for deleting to the beginning or the end of the line. So if I press Control K, it's going to delete everything from my cursor to the end of the line. Or if I go back to that position and I press Control U, it's going to delete everything from that cursor position to the beginning of the line. These are just more convenient, like you have an interesting command and it has a huge like path name at the end, and you just want to like jump into the middle of the command, erase that whole block of text. Scrolling to the right position is relatively safe. You don't have to do anything special. You just scroll into exactly where you want in the command line, hit Control K, and then it's cleared out whatever you like. So I mentioned Alt Dot, that last one on the slide, during the talk about history, so I don't need to go over that one again. But the other two that I like to highlight are Quoted Insert and Editor. Quoted Insert is interesting. If you ever want to get, for example, a literal tab character to appear inside of the input of a command on the command line, if I press Tab, that's going to autocomplete some file names because of bash completion, which I'll mention later. But I wanted to type an actual tab character. I didn't want bash to fill in something or to run some other kind of shortcut. So I'm going to use a quoted insert. That's the Control V. At first, it's going to do nothing, but if I type a tab, now it's going to interpret that tab literally instead of trying to interpret that tab as a shortcut in the command line interface itself. And now that tab is part of the argument for echo. Editor is also a neat one. So my editor, I don't think I have it set. I'm just going to set my editor to be Vim. And now if I have a long and complicated command, maybe I want to do something more sophisticated. I want to edit the command in a text editor, in a real text editor, rather than just read line. If I press Control X, Control E, it's going to open the command in this case, I've just set it to Vim. I can edit that command. And then when I save and exit, it's going to run that command. So this is a more convenient way to make large modifications to a particularly complex command. And similar to the topic of the question? Yeah, the slides are available for download. If you look at my presentation page on the SCaLE website, it'll be right underneath the description of this presentation. There will also be a link to that at the end. So ASCII has some historical context. ASCII is the default character encoding. And what I want to highlight with the ASCII man page itself, and I really mean looking up ASCII in the manual, pressing Control actually modifies the character that's sent through the terminal. Assuming that it's not already a shortcut in STTY or readline or anything else, then Control followed by a character, for example, Control I, is going to subtract 64 from the value of that character, and I'm going to actually get a, in this case, horizontal tab. So let me dive back in. If I was typing that same echo with the tab command, if I press Control I, it's going to be interpreted exactly as if I had typed a tab character. There are a few, let me go back to the man page. There are a few characters, for example, if a major hardware manufacturer decides that they don't need to include an escape key on a keyboard, you could use Control open square bracket to type an escape character. So that way you don't need to rebind something else to escape if you know that you can just type Control open square brace. Likewise, that's how you can find, for example, that the backspace key is actually Control-H, because if you look back in the man page and you scroll down to H, that's actually the backspace key. And I've mentioned that we have auto-completion. So Bash has some really nice features for completing what it thinks that you want to type. So right now, I have a single file in this directory, foo.sh. If I wanted to edit this file, it's very easy for Bash to try and guess and help me out in deciding what files I want to edit. So if I want to run vim, for example, and I want to edit a file, I can start typing that file name. But instead of typing the rest of the name, I'm going to press Tab. Bash is going to look at all of the files in this directory, and it's going to suggest, oh, did you mean to edit? I've just pressed Tab, foo.sh. And it finished typing the rest of the file name. I didn't have to do that. It works also with directories. So if I wanted to cd into a directory, if I wanted to cd to the example directory, if I type E and then tab, it suggested to me that example is a possible completion of that. But if I wanted to use my editor, there's a slight difference. I actually have multiple file names that contain E. There's a customization here. You'll notice that normally complete file names are case sensitive. I have a customization, which I'll talk about in a little bit, that makes this tab auto-completion case insensitive. But the important thing to highlight here is, in the case of editing a file in this particular directory, Bash doesn't know whether I want to jump into the example directory or to edit the example2 file or the example.sh file. This wasn't a problem when I used cd, E, and then tab, because it's aware that the cd command likes to work on directories and not files. So the Bash autocompletion is actually pretty sophisticated. There's customization that you can do. For example, git, and if I press tab, it will also try to autocomplete. So this autocompletion is very context sensitive, and in many utilities, you'll find that it's much easier to navigate all of these different command line options and arguments if you can make use of the Bash autocompletion feature. Check out the man page in the Bash completion section. So if you go to man bash and scroll down to Bash completion, it'll give you a lot more documentation about how this completion is implemented and how to add your own support for your own utilities. So let's talk about customizing the shell, getting some convenience features up and running. I personally like to set my key repeat configuration to have like the maximum repeat rate and the minimum delay. That's partially because I can undo things pretty easily when I'm typing things on the command line. And sometimes I have an extremely long command, and I want to be able to scan back and forth. So if I have the repeat rate set to be very high, then I'm not waiting a very long time to scan to the front or back of this line by holding the keyboard character, by holding the key on my keyboard. So this would be in your local operating system's configuration. Look in the system settings underneath whatever keyboard configuration options you have, and you can tune these variables accordingly. This setting is not for everybody, but I personally like it. Also, take some time to customize the colors and fonts of your terminal. Find colors that are comfortable for you. A lot of people love dark mode. In presentations, I like to use light mode, and then I use dark mode in my terminal later on. If you like more contrast, set more contrast. If you like less contrast, set less contrast. Try and make it comfortable for you. When choosing a font, again, find something that's comfortable. I have a couple examples on the slide. The slides use the Menlo font, but I also really like Hack and Ubuntu Mono. The important thing about is find something that's, number one, readable, and number two, gives you the ability to distinguish between similar characters. So it's very easy to confuse a capital O and a 0 if the fonts look identical, but if they give you some kind of hint with like a slash or a dot that they are different characters, it'll reduce the risk of typos or misinterpretation later on. Another customization in Bash is to customize the prompt. So PS1 is a little string and syntax engine that runs to display the prompt for your shell. So if I'm in Byobu, it gives me a little bit of context about what's happening right now. So it highlights, this is part of the Byobu default configuration. It highlights my username in one color, it highlights the host name in a different color, and it highlights the directory in another color. So my username is blue, my host name is red, and my directory is green. This gives, color is a great way for humans to distinguish different pieces of text in context. Byobu also provides exit code highlighting. So I'll get into a little bit more detail in a few slides, but sleep 1 is going to exit successfully, and so it doesn't need to tell me any additional information. But sleep infinity, followed by me killing it or telling it to interrupt by pressing Control-C, that's going to tell me that, oh, this was not a successful command. It actually exited with exit code 130. So the actual output, it only showed me a little caret-C for Control-C. If I had a command like false, there's no feedback on the terminal besides what I've configured in the $PS1, that Byobu has configured in the PS1 to tell me that false actually didn't do what it, didn't complete successfully. For additional configuration options, check out the man page for bash and scroll down to the prompting section. Another popular customization for your prompt is to include some context about your version control system. So it's fairly common for your prompt command, or rather for your PS1, to include some information about which branch you're currently checked out on, or if you have any local changes that haven't been committed yet. Check online for additional customization options. Lots of people online have written recipes for you already. So some of the other customization has to do with readline itself. The configuration for readline is going to be set in the .inputrc file in your home directory. The man page for readline gives detailed descriptions about what each of these things do, so I'll just highlight a couple of them here. So blink matching paren, if, for example, I have, if I close the parenthesis here, what it's going to do is it's going to flash the opposite parenthesis. It's going to show me which one matched. When I have a single layer of parentheses, that's not so interesting. But if I have multiple layers, like I have some square braces open and curl braces, and then I want to close the curl brace, it actually gives you a little bit more context. Okay, what actually matched the character that I've just typed? And so you can be, this is a way of reducing typos even further, because you get some feedback about how things line up in the command itself. So I mentioned that the auto completion is normally case sensitive, but I've configured it to be case insensitive. That's this option completion ignore case on. You can check out the man page for additional details about all of these configuration options, and I would recommend actually reading the man page before copying and pasting this into your own config, because some of these change the behavior of the shell in ways that you might not expect at first. So actually check out the man page. It's meant to be read by normal human beings, so you can find out what all of these things actually do. If you have some commands that you type fairly frequently, or some options on commands that you use very often, you can use aliases and functions. So 3 examples that I have. So this is how you would, I'm going to give 3 examples of things that I do fairly often, and then in the next slide I'm going to show you how to make those more efficient. So the IP command is really cool. It shows you information about, in this case, all of the IP address interfaces that are available on this machine. But as a human being, it's hard for me to read, okay, which part is the IP address? I have more than one interface here, so this is the IP address and this is another IP address. It's hard for me to visually scan this. So more often than not, when I run the IP command, I actually would prefer to run IP-C, which enables color mode. So now the output is color-coded, and it's much easier for me to see as a human being, oh, this is an IPv6, this is an IPv6 address, this is an IPv4 address, here are some MAC addresses. So I want to be able to just if I had my way, I would love to be able to just replace the IP command and always run it with the -c option. I can do that with an alias. Awk is another neat command. So awk is a language unto itself. We'll mention a little bit later. But awk, let's do here, print $3. Let's go and do proc mounts. So this awk with print $3 is going to print the third column of proc mounts. I could replace this number. So if I wanted the second column, I can use a $2. This is just it's pretty frequent that I like to extract a particular column from a file when the columns are separated by white space. So I'm going to make that more efficient in a moment. And also, it's also pretty common, like I want to make a directory like cool, and then I want to cd into that directory. I've just made the directory. I probably want to go in that directory. So I want to cd into cool as well. So let's make these more efficient. So this is what you would put in your .bashrc, for example, to create shortcuts for each of these options. So the alias IP is equal to IP-C means that any time I run IP, it's going to be transparently replaced by IP-C. So now, whenever I run IP-A, it's always going to give me color, and it's always going to be easier to read. This field, so this is a function. Functions can be slightly more sophisticated than aliases. So this function is going to do something a little bit more convenient. So I can pass in the column number that I want to affect as an argument onto field, and that will be substituted inside of the awk script. So now field 3, taking input from proc mounts, prints the third field, and then field 2 prints the second field, and so on. And then mkcd. So this function is going to take an argument, it's going to create the directory, and then it's going to cd into that directory. So mkcd cool2 is going to create that cool2 directory and then immediately cd into it. So you can create any kinds of shortcuts that you like with aliases and functions. Let's talk about some of the cool command line tools and utilities available. So the GNU core utils are a fantastic collection of utilities, just general purpose utilities on the command line. I want to highlight a couple here. So I'm going to use my field script from before to show you a couple things. So the third column in proc mounts tells me the type of the file system that's mounted for each of the mount points in my system. They come in whatever order that the mount kernel utility considers convenient. So if I'm consuming this as a human, maybe I want to see the items in sorted order. So if I pipe anything into sort, it'll give me the elements in sorted order. There's also a unique command, and you can string that together as well. So now unique, its entire purpose is to eliminate adjacent duplicates. So it has done exactly that. I no longer see so many squash FS's in the output. But that's actually not the best way to do this. Sort has a -u option, which will do exactly the same thing. But maybe I'm not interested in the list so much as I'm interested in how many of each I have. So unique has some options that sort does not. Unique -c will print out in front of every line the number of times that that text has appeared in the output. So I can see that I have 8 squash FS file systems in this case. But maybe I want to sort that again because I want to see the things that are most frequent. So I'm going to pass that into sort again with the -n option. This means that it's going to sort these numerically. So by default, like 1 comes before, or sorry, 2 comes before 10. Sorry. By default, 10 comes before 2 because 1 comes before 2 because that's the first character. When you sort things numerically, it's going to interpret the first field as a number. So now I see if I've run with sort -n at the end that my most common file system on this machine is actually C group. This idiom of using sort pipe unique-c pipe sort-n is an illustration of how powerful these commands actually are. If you had to write a C program to do the equivalent, you'd be having a pretty hard time. And compared to writing just a few pieces of text in Bash, that seems a lot easier. Column is another really cute command. So if you have a list of, let's actually go 30 of those. So if you have a long list, like the output of the ls command, everything appears in nice, neat columns. That's empty, so there. So ls prints things out in nice, neat columns. It tries to conserve space on your terminal as much as possible. So if I have a command that prints out very short pieces of text that I'd like to read in columns, I can instead pipe that into column, and it prints them out in nice, neat, compact columns. That's not actually what I use column for most frequently. I actually use it for, let's find this. So this is a little bit complicated of a regular expression. Don't worry about it. But what I'm going to do is it's just going to print out all of the elements from my fstab configuration file. This configuration file uses white space to separate each column. And in its default formatting, it's pretty hard for a human like me to read. If I pipe that into column-t, it's going to separate each of these columns in each of these fields into vertically aligned columns. So now this is much easier for me as a human to read and parse. The documentation for the core utilities are fantastic. There are man pages for each of these. You can check out the GNU website. There are also info pages for these, which go into much more detail than the man pages would normally. There are additionally lots of advanced tools on the command line that can do some pretty sophisticated things. Xargs and Parallel I sort of group together in my own head. What these two are designed to do is to take a long list of input and run it as arguments to a command. The example I have of this has to do with find. So let me jump into find, which is my second example. So find searches for files and directories. Pretty simple. I'm going to give it a path. In this case, I'm going to find inside of my pictures directory. And I'm going to do a case-insensitive search for any file name or directory name that looks like screenshot followed by any number of characters followed by .png. So in this case, it found a few screenshots in my pictures directory. I can then pass this into Parallel, for example, and run a very expensive long-running command. So optiping just recompresses the file, so it'll hopefully be a little bit smaller. The important bit here is that I'm passing the output of find into Parallel. And what Parallel is going to do is I have a fairly powerful laptop, and I have an even more powerful development machine remotely. It would be pretty terrible if I could, like I have a handful of files here. I want to be able to use all of the power, all of the different processor cores in the system to be able to churn through all of this long-running work. So if I were to run this using Parallel, now I get one separate instance for each of the instances. I get each instance of optiping, in this case, to run in Parallel. I've told Parallel to process 50% of my cores, which in the case of this laptop is 6 instances. And I've also given it the ETA option, so I have some live feedback about how long this is going to take, based on how long it's taken to process elements already. So I'm just going to kill that because we don't need to wait for it. PV is another favorite command of mine. It's designed to give you progress information about a pipeline or reading a file. In its normal use, let's do dev view random, and I'm going to pipe that, just discard that to dev null. So this is just going to read from one endless stream of random bytes and discard the output. But what PV is going to do is it's going to give me live feedback about how much data is going through the pipeline and how quickly that data is being processed. PV can do some pretty sophisticated things. So let me grab my example command. Just give me a moment because it's a little bit complex. So here I'm going to read this file, I'm going to decompress it, and I'm going to pass it to PV again. I'm going to compress it, and I'm passing it to PV again to save it. So this actually gives me context about each part of the pipeline as it's running and how quickly the data is being processed in each part. Unfortunately, I must have a typo, but this is some good context about how quickly a process is going to churn through data. Cool. Some more sophisticated utilities. I mentioned man and info before. If you are ever curious about like how does a command work, what are the additional options I can do with that command, the man command, so you just like, if you were interested in how bash works, man space bash would show you the documentation for bash. And some utilities, like the GNU core utilities, also have info pages. So info for less is going to give you even more detail about less and how it works. In this case, yeah. grep, sed, awk, and Perl are all heavily invested in regular expressions. This is a special language to be able to match or identify particular patterns in text. If you haven't been hugely involved in regular expressions before, they are a very powerful tool in command line utilities and in programming in general. It's a little bit difficult to get the hang of, but once you do get the hang of it, you can do some fairly sophisticated things with a fairly compact string of characters. If you want some resources to learn how to use regular expressions, I've got a couple sites here. Regexer is going to give you detailed information about, like you paste in a regular expression, you want to know how it works, it's going to give you detailed information about exactly what's going on inside that regular expression. And then regex crossword is a way to practice regular expressions. Let's talk a little bit about the shell. So I mentioned that shell commands have exits statuses. So the true command does nothing, and it does that successfully. Byobu is going to be especially illustrative in these examples. The false command is going to do nothing, but it's also going to fail at doing that. And by fail, I mean it's going to output nothing, but it's also going to set its return code to 1. Anything other than a 0 as a return code is considered unsuccessful. You can string commands together. So if you use a semicolon to string commands together, then each command will run in sequence, regardless of the exit status of the previous command. This is an extremely dangerous command to use, however, because what if, for example, I don't have an SD card mounted in this machine? It's going to run the CD command, that CD will fail, and then it's going to run the RM regardless of where I am in my file system. Like if I'm in my pictures directory, that's not going to be a great situation. You can string commands with an ampersand, in which case it will only run that second command if the first command succeeded. It can get a little bit complicated to string commands together using the and the or options, but just be aware that you can string them together in that way. Likewise, isn't it curious that when I have sleep infinity, if I hit Control-C, it's not like a 1 that gets outputted, it is a very particular number. So in this case, 130 is actually, it corresponds to the signal that was sent to that process. So if I look at what signals we actually have available, sig int is number 2, and it just so happens that 130, which was the exit status, is 128 more than the signal that was sent. So this is actually a way to tell like what kind of signal might have been sent to that process. If you ever want to see the exit status, if you ever want to use it later on in a script, it's in the $? variable, and you can use that in a bash script later on. It's also worth mentioning pipe status. Because it's perfectly possible for some part of a pipeline to fail, even though the first and latter parts actually succeeded. If you ever need to detect that, there are two ways of doing it. The pipe status array in bash contains the exit status of everything in the previous pipe that ran. And also, if you're writing a script, which we'll get into later, you can also set the pipe fail option, which would abort the script in case something in the middle of a pipe failed. Job control, let's dive into that. I have just a few minutes left. So I have a long-running command, which will actually take forever to finish. So I want to continue using this terminal, but I also don't want to kill my long-running command. So what can I do? I'm going to type a Control-Z, and that's going to stop the command and push it into the background. So now the command is stopped. I can resume that command in two ways. I can either use FG to bring it back into the foreground so I can continue watching it, or if I push it back into the background again, something that's stopped isn't actually progressing. If I want it to actually keep processing data, I need to specifically background that process. So BG is going to push it into the background, and then that process is going to continue running and hopefully finish. So let me bring it back into the foreground, Control-C to kill it, and do this with a little bit more of an interesting example. So sleep 1, I'm going to immediately background that, so it's stopped. Because it's stopped, like sleep 1 is supposed to exit in 1 second, but it's stopped, and because it's stopped, it's going to continue running until I, for example, background it. And since I backgrounded it and more than 1 second has elapsed, then the program completed the rest of its processing. You can operate on particular commands, like the examples here were prefixed with a 1. So if you kill %1, that would kill that first job in the list. You can list all of the jobs with the jobs command, and if you want to launch many, many things and then wait for them all to finish, then you can use wait. Bash has a lot more sophisticated control flow. Some of the examples are on the board. I'm not going to dive into detail here. Just be aware that it is a programming language. You can do some pretty sophisticated things in it. I love Bash. I like to use Bash for very small scripts, but if you're doing something very sophisticated in Bash, like if you're writing a 1,000-line Bash script in a file, that's at a point where I would kind of suggest that you start looking at other languages, because really complex programs, Bash sometimes isn't the best choice for that. But if you are writing a Bash script, I want to give call out. So here, this is a safety option at the start of a script. It's going to do a few things. Set-E, if any command in your script exits with a non-zero status, it's going to kill your script immediately. It's going to stop processing. It's going to exit. That's great for safety. Like you can run cd and then dive into and then try to remove files from a directory. Set-E is going to protect you from that cd command failing and accidentally removing files where you didn't want to. The U option protects you against the use of unassigned variables, because if you try to use a variable that you didn't assign a value to, Bash is going to, in the case of this, rm-rf, let's do, if I didn't actually define what directory was, then this is a very dangerous command to run. Set-U is going to protect you in that instance. And finally, I'm going to highlight shell check. Shell check is an amazing project. It's a linter for Bash scripts. And it's going to parse through your Bash script, and it's going to give you advice about common mistakes, common errors, and in general, try and help you improve the quality of your scripts. One of the other engineers that teaches this class at Facebook likes to say that scripting without shell check is like driving without a seatbelt. You can do it, but you're not going to be safe. Thank you for attending this talk. I wanted to leave you with a few links, so if you can grab those, otherwise I'll put them on the slides. The link on the left is the slides for this talk. The link on the right is a link to engineering.fb.com. I will be around for a few minutes after the talk to answer any questions, but I think I am exactly out of time, so thank you for coming.
All right, Bob, are you ready to learn about Kubernetes release notes? Excellent. This is a story of GitHub screenshots and Rick and Morty. Just to start, this is me. I have a little bit, this is so funny because it's just you and me. I have a little bit to say on release notes. I've been part of the release notes team for the last 4 quarters, so 1.14 through 1.17. Come on in. Yeah. Just my name. Yep. He's my best friend, so this is just going to be me doing the thing, like doing the presentation to him anyways. Anyways, you actually don't know this. So I have been on the release notes, well, the release team for the last 4 releases, 1.14 through 1.17, and then for 2 of those, I was focused solely on the release notes process in the release team. So I kind of want us to take a seat on the couch and watch some intertemporal instead of interdimensional cable. We're going to jump through channels in time, and we're going to see the history of release notes in Kubernetes, because it has taken many different turns to get to where we are and where we're going. But first, something to consider is imagine that there's a new Kubernetes release. It's shiny, new, and cool. What new alpha features are there that I could turn on for my cluster? But then reality sets in. If I upgrade to this version, what the hell is going to happen to me? Are there breaking API changes? Has this feature I've built our entire application on become deprecated? Enter release notes. Release notes are just a changelog for identifying differences between version X and version Y. Enter release notes. They're an effort by the community to inform users inward and outward facing of upcoming changes. Enter release notes. Release notes are fields added to a PR template to help automate changes. Enter release notes. Markdown published at each release. And it's also a website. This slide became really busy because there is now a lot going on with release notes in Kubernetes. So where the hell did we come from? Kubernetes has been around a while, almost 6 years. Have release notes always been this big and this complex? No. We started with humble beginnings. Kubernetes 0.4 is really the first changelog that I could find, and it is literally 1 entry and a date. So we started extremely small. Things started getting a little bit more complex in 0.5 as the project started ramping up more and more. I remember when we installed Kubernetes 0.4 back in 2014, it seemed really complicated, and we couldn't keep up with the trajectory of all of these changes. Because, I mean, these were game-breaking changes within Kubernetes, and even with a proper changelog, we just couldn't keep up. And as you can see, now there are totally different sections instead of just 1 entry. So you have features, and then you have cluster and cloud support, whatever that means. 0.6 and 0.7, it became very obvious that release notes were not the priority. They occurred afterwards when there was time. That's how fast things were moving back then. Also, because it is literally just us, I was actually going to pop open each of these release notes in GitHub and scroll through and show them. We're going to go ahead and skip that. 0.15, they started using this magical thing called the release page. This is a GitHub feature, and they stopped doing the idea of publishing Markdown. It stuck around through 0.17, and they started breaking things up into better sections. And then from 0.17 on with the release page, things were good. The GitHub release page seemed like a really good match made in heaven for Kubernetes and all of the, collating all of the release notes. And this is actually how they primarily published release notes until Kubernetes 1.2. And then this whole new format came along. Mind you, it's a cleaner page, there's a lot more information, but this kind of seems a little auto-generated. I doubt anyone actually made this by hand. So what made this? This is a tool called Anago. Anago is something that is written in Bash. As with everything in Kubernetes, we have to over-engineer a solution and first write it in Bash. It worked well with, for kubeproxy, and it will surely work well with our release tooling. And it does eventually lead to some memes about preventing bash fires. This was one of those instances where I was going to click and actually go through Anago and the rel notes bash script. We're not going to do that. Anyone that has ever had to work on Anago in the last 2 years did not really have a good time. So, now we're at Kubernetes 1.5. There's this concept of the release notes draft. Anago would actually publish a release notes draft for whoever was shepherding the release through to see what release notes were going to get published and maybe add a little bit of an editorial eye to it. Because it's really just looking at PR comments and then taking the PR comments and throwing them into Markdown. That's how this was working in the background. But then in 1.6, there was this idea of a Kubernetes release team. So, together we're stronger, and the release teams form. The one thing of note is even though there was a release team, there was not actually a release notes role yet. The features lead of the release team was responsible for the notes wrangling at the time. Did you know that? Eeyore did that for a long time. In Kubernetes 1.7, people in the Kubernetes community may know, Brian Grant, filed a very lengthy issue called New Release Notes Process and Guidance because it became unwieldy that the release notes getting published were just incredibly long and very difficult to parse and grok and do anything meaningful about. But in Kubernetes 1.8, the release notes role now became part of the release team. That was one of the actions that occurred directly from the issue that Brian Grant created. And then it was good for a time. We were actually, nothing really changed between release notes and Kubernetes from 1.8 to 1.12. Release notes were what I would consider in a stable state. But as with all things, engineers have to engineer, and we have to try and make something perfectly level. So then we decided to start rewriting how we generate release notes to make it more of a Kubernetes native thing in Golang, rather than a dumpster fire bash script. I shouldn't really say it was a dumpster fire. It was incredibly stable. It was just a very complicated bash script. So let's make a Golang tool out of it. So Mike happened to be one of the release notes shadows at the time, took it upon himself to write a release notes tool. And an interesting thing was his release notes tool wound up staying in his own personal repo for the next 3 releases, 1.12, 1.13, 1.14. So, okay, we now have this logic of we now use this Anago script. Anago does all the Kubernetes builds and all the release notes, but we also now have this Golang tool to generate all of these release notes. How do they work together? They work together. Let's just keep Bash and Golang together. Why not? In Kubernetes 1.14, I became a release notes shadow and had this really weird idea from my background being a web designer. Let's just generate an actual website. At the time, the markdown that was being generated was literally 30 pages. Like for a single Y-stream release, it was 30 pages and very unwieldy. So if you're trying to like figure out if there was anything networking-wise that may have changed, am I affected or not? You couldn't do that unless you were like control-Fing certain phrases. Let's make it easier. We already have all these labels and automation around our PRs, so let's do the same thing around our changelog. So in 1.14, I created this POC site. No one was really using it. It was really just, hey, can you take a look at this, see if there's anything we should add? There's quite a lot we should add. In Kubernetes, there is this concept whenever you are doing a user-facing change or a cross-SIG or special interest group effort to create a KEP. That's really just to, it's a Kubernetes enhancement proposal meant to track our effort across the project. So I wrote a KEP about release notes, and one of the chairs of SIG release and also SIG PM, Augustus, is all about KEPs. And his lovely face has to be wherever I say KEPs. So in 1.16, that proof of concept that I wrote wound up being one of linked within the release notes. So we kind of did this whole dual branch. We would publish the markdown, but also, hey, there happens to be a link to relnotes.k8s.io. Please look at that. And then several people tweeted it, and it was actually, we watched our Google Analytics go whoop. So that was nice, and we got some really meaningful feedback. This I will click into, if it'll work. So part of the problem here is all of these are different labels. Literally all of these are different labels, and we're tracking different releases. So even though this is now one of the ways that you can consume release notes, it itself is still complicated because we are such a complicated project. So I'll get into kind of future state and how we're trying to tackle that later. So around 1.16, there was this concept called release engineering. So at the time, everything regarding releases, publishing releases, wrangling people into releases, it was part of the release team. So it was this mix of technical roles and kind of project management. So Augustus had a wonderful idea of breaking out the technical roles from the PM and kind of just release wrangling roles, and that was called release engineering. It became a sub-project under SIG release. And this kind of, you'll see where release notes is going because it becomes more of a technical role than a wrangling role. So where are we right now? This is the process to generate release notes from the start of a pull request to it being published either in the markdown or in the release notes website. So as part of a pull request in Kubernetes, there is a template where you have to type in whether this is a user-facing change or not, and what the user-facing change is. Release notes members on a weekly basis will generate both a draft of the markdown and a draft of the website, and that will automatically pull those templated fields and then make it, nice and pretty. Once we are ready to actually do a release, they will PR things against the SIG release and the release notes repo, because SIG release has the markdown draft. The release notes repo has the JSON. The editorial process occurs where it's really just, okay, are we all using the same format, the same verbs, all that. And then once the Kubernetes version is actually released, comms are sent out, and then the final release notes are PR'd in. We try to PR them in a little bit before the actual release occurs, so it depends on kind of people's timing. So, literally this release, I'm not sure if you knew this. He's on the release team right now, so I'm going to bother him. But literally this release, we have started phasing out Anago and then doing a lot more with Golang. So there is, as part of the release engineering effort, they're slowly but surely replacing bits of Anago's functionality with purpose-built Golang. And one of the things was actually using the Golang tool as part of their release process. So we are slowly but surely automating the release notes process rather than making it a manual one. So looking forward, we actually still have to meet all of the goals of our KEP. One of the goals of our KEP was being able to automate everything, and we're almost there. So we need to finish that before we get any other crazy ideas, but we'll probably get there within the next quarter or so. Part of that plan involves cruise control. So like I said, automating and the publishing of release notes to the website is currently underway. That's going to involve publishing JSON to like GCS or an S3 bucket and then pulling all of those and having the website pick them up. Another idea that we've discussed is allowing end users to be able to subscribe in some way to types of changes and doing a sort of push notification to a group if certain criteria is met. So pushing a changelog to people that is relevant to them rather than expecting them to look at the release notes every time. So if you are so inclined to go and visit the website, please help us out. It's relnotes.cates.io. If you look at the top right, once you visit the website, there's some about link. You'll get the kind of TLDR of the project, but there is also a link to a survey because we need more feedback. This is all more end user driven. So Rick and Morty belongs to Adult Swim. The Road to El Dorado belongs to DreamWorks. Steven is absolute meme fuel, and everyone loves Kubernetes that's in the community. I get to do cool stuff at Red Hat, so I have to shout out them. Thank you for letting me do stuff, you know, on their time, but being part of the community. And hopefully, I will see you next year. And wow, that was 16 minutes. I figured I would do at least 20. Thank you. I did skip literally all of me opening up GitHub pages and explaining scripts, but I'm okay with that for this. Do you actually have any questions? Because I don't know how much you know about like Sasha and the KREL stuff with release engineering. Cool. Do either of you have any questions? I mean, don't dig if you don't have one. It's okay. All right. Thank you.